Previously we talked about how to find LCM and GCF, and there's two scenarios: either you're given numbers or you're already given their prime factorizations. So here's a slightly trickier set of examples to make sure you guys really have it and you can practice it a little more. So let's say you're given this prime factorization. Not a prime factorization. So let's say you're given 12 to the 10th power times 20 to the 4th as your first number, and your second number is 8 cubed times 12 cubed. So you might be tempted to say, okay, what do these share? Okay, well they share 12s, so for the LCM I'll take the higher power or whatever. The point is you can't start doing this until you've gotten the true prime factorizations from here. These are not prime numbers. So the 12, the 20, and the 8 need to be broken down. Same thing here. So if you have these sorts of questions, first get the prime factorization. Now, rather than multiply all this out and then go backwards and find the prime factorization, we're going to see how to do this very easily. And also, we're going to learn exponents later, but we're going to do this with some vague knowledge about exponents in a non-exponent sort of way. So in a easier, more conceptually easy way. So for example, a 12. What is a 12? Well, it's a 3 and a 4. All right, and a 4 has two 2s. So we want to replace these 12s with their prime factorizations. So since one 12 has one 3 and two 2s in it, and there's 10 of these 12s, then there's really 10 3s. And because a 12 has a 4, which is two 2s, so we have 10 groups of two 2s, so that's 20 2s. So again, let's review that. There's 10 12s, and each 12 consists of a 3, a 2, and a 2, so that's 2 squared. Now since there's 10 of these, that means that we have 20 2s, because what is 2 squared? It's 2 times 2. So we have 2 times 2, 10 times, so there's 20 2s. So that's where we got this. So again, we're not applying exponent rules blindly, we're actually figuring out what this means. So that will be the 12. Now the 20 is a 4 and a 5, and a 4 is two 2s. So two 2s repeated 4 times is 8 2s. So that's the 8. And there's 4 5s because a 20 has a 5 in it. Alright, so all we've done here is just express this first number in terms of prime numbers to powers. Alright, let's go to the second part. An 8 is 3 2s because it's 2 cubed. So 2 cubed repeated 3 times, multiplied by itself 3 times. So it's 2 times 2 times 2, 3 times. So there's 9 2s. So again, you could use knowledge of exponents to say a power to a power, you multiply the powers, but we want to figure it out from scratch. So I don't want to use any exponent rules. All this means, so if 2 cubed is 2 times 2 times 2, and we're doing this 3 times, so you could just count up that there's 9 2s, so there's 3 of these. Alright, so that's the 8 part. The 12 part, again, we've already done 12, so it's a 3 and a 4. So there's 3 3s and 3 4s. Each 4 is 2 squared. So 2 2s repeated 3 times means there's 6 2s. So that's step 1. We've broken all of these numbers in composite numbers, which means they're not prime, into prime numbers. So now let's group all the parts together, because we have some 2s here and some 2s here, some 2s here and some 2s here. So if we have 20 2s multiplied by another 8 2s, altogether we have 28 2s. Again, I'm not relying on an exponent rule which says add the power. We're just figuring out that that makes sense. Alright, let's bring this over. And then here there's 9 2s multiplied by another 6 2s, so altogether we have 15 2s. All right, it's only at this point that we're ready to find the GCF and LCM. So for the GCF, what's the minimum here? We pick 2 to the 15th. They have 3 3s in common, and they don't share 5, so this is your GCF. LCM, we go the other way. We take the maximum, so that's 2 to the 28th, 3 to the 10th, and what's more, 4 5s or no 5s? 4 5s, so 5 to the 4th. All right, so this is the answer to the first question. So I'm gonna leave number 2 as an exercise, but the procedure should be the same. So for number 2, your first step, you want to break your 4, 9, 15, 4, 8, 12 down to prime numbers. So this will be 2 squared, 3 squared, 3 times 5, 2 squared, 2 cubed, 3 times 2 squared. And then you would apply, for example, I'll just do this first part. So if you have 24s, that means you have 20 groups of 2 2s. So that's 42. So you would replace this with 2 to the 40th power. And you would do something similar for all the other stuff. 11 is already prime, so you don't have to touch that. So step 1 is break everything down to prime numbers. Next step, as we saw in number 1, we group together all of our prime numbers. So you may have some 3s from this 9, and then you may have some 3s from this 15. So you're going to aggregate or group all the 3s here, and let's say some 2s are going to be coming from all of these. So once you've grouped all your numbers, then you'll have a prime factorization, and only then will you be able to do this. All right, enjoy.